Next, continuing from the VLAN topic, now we'll talk about something called forwarding between VLANs. See, if you create a campus LAN that contains many VLANs, you typically still need all devices to be able to send data to all other devices which are part of different VLAN. Meaning, sometimes you want VLAN 10 to communicate to VLAN 20. Yeah, there can be some need here. Sometimes VLAN 30 PCs want to communicate to VLAN 40. But normally, direct communication between two different VLAN is not possible. To communicate between one VLAN to other VLAN, we have to use one of these three methods. We have to use either SVI, Switched Virtual Interface use பண்ணணும், or you have to use router on a stick concept இருக்கு, அதை use பண்ணணும், or else you can using layer 3 ports in a switch. We can do that. There are three methods available. So out of these three, we have only one topic called router on a stick as of now in CCNA. So we'll focus on that one. So if a router on a stick, what we are going to do? We'll be using a external layer 3 router. So using a router, I will be taking my traffic. Think like this. In a LAN, every device have to be in the same network. Similarly, each VLAN should be part of different network for the communication. Between two network, we need to have a router. Meaning, see if this is VLAN 10, here it will be in 10 series IP address, maybe 10.000/24. இது வந்து 20 na, maybe it is 50 series IP address. So it's obvious that this network and this network will be different. It will be N1, this will be N2. So all these for every one of these guys, I will be taking one cable that's going to go a router. In the router, in the interface will be 10.001. Here it will be 50.001. So they will act as a default gateway for all my PCs. Now, what is default gateway? So default gateway is an interface IP using which my PCs can go out of my network. In network தாண்டி நான் வெளியே போகணும் அப்படினா, I will be using default gateway only. So default gateway is what we use to go beyond my network. So imagine you take a PC here, one more PC connected to a switch. There is one more PC, there is one more PC going to a router, going to internet. This router's interface, maybe node IP 10.1, this IP 10.10, and my default gateway is 10.1. Here this IP is 10.20, my default gateway is 10.1. My interface IP is 10.30, default gateway is 10.1. Namari, for everyone, default gateway will be 10.1 only. So when PC1 want to talk to PC2, it can go directly through switch போக முடியும். If PC1 want to communicate to the internet, it has to go through the default gateway. So default gateway is used only when you want to go beyond your network. Within network, default gateway தேவைப்படாது, not required at all. Clear this part? Now, so I took two interface, FA0/0. I took 0/1 also because I had two VLAN, VLAN 10, VLAN 20. What if I got VLAN 30, VLAN 40, VLAN 50, VLAN 16? ஒரு VLAN-க்குமே I need to take one link from here. Then only that VLAN traffic can come to that interface and it can go via other interface outside. So if I got 10 VLANs, I need to have 10 physical connections on my router, which is quietly not possible. Yeah, it's not possible to have 10 links and all here. So what we can do? What is the best practice? So the best practice is I can use one single interface and I can split the interface into two pieces. என்ன பண்ணலாம்னு சொல்றானா, you take one single physical interface FA0/0 and you create a sub interface, meaning breaking one physical interface into two or more pieces. I can even break into 10 different pieces. So your configuration is very simple. You have to simply go to router and type interface FA 0/0.10 or 0.20. The mari we have to type. If you type this, automatically FA 0/0 length 0/1.0 will be broken down into one piece. So imagine you have taken one single copper wire like this bundle. It's almost like when you make FA 0/0.10, 0/0.20, you are splitting one copper wire into two pieces. So it's obviously that when you cut them into two pieces, you have to again insulate it, right? We have to do insulation again. Only then it can work. So like that, I'm doing insulation with the tape now, extra tape. Here I'm using insulation for that sub interface using VLAN 10. See, in the number can be anything. In the number, no need to match with your VLAN number. This can be any random number also. Encapsulation .1Q10 na, I am telling that on this sub interface only VLAN 10 traffic has to come. அப்படி ஸ்பெசிஃபிக்கா நான் சொல்றேன். Next, I'm giving the IP address. The IP address is 10.001.255.0.0.0. Nothing but my VLAN 10 PC order default gateway I'm giving here. Similar way, I'm taking VLAN PC3's default gateway. I'm gonna configure here. So I'm telling encapsulation .1Q20 and give the IP address. And by default, you type no shutdown on all. So this port has to be a trunk port, and this has to be a VLAN 10. This will be VLAN 20. So the condition is we got a PC1, PC2 in VLAN 10, PC3 in VLAN 20, and they want to communicate. But traffic will come here, go through trunk interface. Here trunk allows both VLAN 10, VLAN 20 traffic. But router we got one physical interface, so we broke them into two pieces. Once we broke them, we are encapsulating it with the .1Q encapsulation with VLAN .1Q10 and .1Q20. So that traffic can come in via him and we can go via here. So the router basically does routing. Routing பண்ணது between VLAN 10 and VLAN 20. So is this clear? If you have any doubts or questions, please ping in chat or ask me. So now let's talk about the voice VLAN. See, I can call it as a magic VLAN. Normal way, if you take one single switch, or portla, we can configure only one VLAN. One access VLAN only we can configure. It can be like VLAN 10, VLAN 20, VLAN 30. So you type switch port mode access. For switch port access VLAN 10, switch port access VLAN 20. The Mari, we can configure access VLAN. Now the point here is, if you configure VLAN 10, it will become VLAN 10. If you configure VLAN 20, this will replace VLAN 10 with VLAN 20 a change ayum. Rendume it won't get configured in all the year. It will get replaced. Next, if you configure VLAN 30, 20 will get replaced. So meaning in a single switch port, I can configure only one single VLAN. We cannot configure multiple VLANs and all here. Only one single VLAN we can configure. So in that case, what if I'm getting my internet service via Cisco IP phone? Normally, or 30, 40 years before, think like this. You'll get internet service to you through a phone, telephone, right? One cable will come from IP phone to the switch. From your telephone, one cable will go to the PC. So your telephone inbuilt has two things, switch and an IP phone. It has both of them. When it has both of them, your telephone voice traffic and data traffic both has to come to same link. Switch port same link unga voice traffic as well as your data traffic varum. When both of them come here, the problem is priority. I cannot prioritize my voice traffic over my data traffic. See, unga voice traffic it's live traffic. Live traffic it get easily impacted by bandwidth issue and all. If you want data traffic and voice traffic to come into same link, but if you want voice traffic to get more priority compared to data traffic, in that case, we have to use something called voice VLAN. Simple on the interface switch port, voice, VLAN, and give any VLAN number, 101, 102, whatever you want, you can give. So once you configure that, voice traffic, every voice traffic will come to VLAN 101, and from 101 VLAN, you can give priority with the help of a topic called quality of service. So I can use a QoS service to get priority for my voice traffic. Simple access you can configure voice and you can use the number 101, 102, 10, 20, 30. Whatever you want, you can use it. Simple. So these things we already finished, lab part and all. Okay. Now we'll go with the VLAN Trunking Protocol, VTP. So it's a protocol developed by Cisco to send VLAN information from one switch to another switch instead of configuring every switches. See, imagine that you work as a network engineer for a very big building. Okay, each floor has hundreds of switches. And each switch we need to configure 200 of VLANs. So, 10 floor irukke. Oru floor layume I'm having hundreds of switches and each switch has 200 VLANs we have to configure. So it will take around 2 hours just for one floor. And you need to go from first floor, second floor, third floor. We have to log into each and every switch, and then we have to configure 200 VLANs. So, which is not a feasible option. இதான் வந்து ஒரு பெரிய problem. See, I always tell, whenever you study networking, any topic, first find out the reason why you are studying. எதனால அதை படிக்கிறோம்னு சொல்லிட்டு first கண்டுபிடிங்க. அதுக்கப்புறம் you start understanding the concept. Now you understood the problem, right? It's not easy for me to configure 200 VLANs in each 100 switches. I may do mistakes also, human errors. Appo what we can do nu yosikumbodhu dhaan we thought of going with VTP, VLAN Trunking Protocol. See, VTP, I will simply take one switch and I will configure the switch as server mode. Here, I'll configure it as a server switch. So server switch, we can configure all the VLANs. VLAN 1 lane there till everywhere. I can configure the server switch. After that, we'll go with the other switches. I'll configure it as client. See, in server switch, you can create all 200 VLANs. And when you configure client here, automatically the switch, server switch will go send traffic to client. Automatically client comes to draw. That's a easy part of it. So server will send to client and client will send to other client from this to other client. So what if there is a condition that I don't want VLAN to be on my particular switch 3. In that case, you configure it as a VTP transparent mode. See, you create this switch as server switch, everybody as client. See, once you configure switch 1 as server switch, you configure all the VLANs here. Once he becomes a client, right, automatically he'll get the VLAN from him and he will update its own VLAN database. Adhe mari from here to inga varum, but without updating its VLAN database, it will go here. Inga vandirum. So that's simple it is. And to configure VTP also, it's very, very easy. Go to configure mode and type VTP domain Cisco. Then you configure VTP mode as either server or client or transparent. Adukapura you configure VLANs only on the server switch, not on other devices. Next is your VLAN trunking, dynamic trunking protocol. See, we know already that I can use a command called switch port mode trunk to make a port to work as a trunking port, right? If the trunk is I can easily change it. But what if I want to dynamically make a port as trunk port? Imagine a condition, this switch is managed by you. This port you have given to your customer. Customer is saying, sometimes now வந்து இதை switch கூட connect பண்ணுவேன் and sometimes I'll connect to my PC. So when I connect to my PC, you should act as a access port. When I connect to a switch, you should act as a trunk port. Appo you cannot make one engineer to work on this part, right? Only on this part, if you tell him to work, it becomes too problematic. Appo you can use DTP, Dynamic Trunking Protocol. Dynamically, you can change the trunking feature of my particular switch port. See, we know that trunk port can send and receive multiple VLAN traffic. So one side you can configure switch port mode dynamic desirable. If you configure desirable at one end, other end as auto, see by default all ports are auto only. They can become trunk iron. They can become a trunk link. This side auto, neighbor desirable also, no problem. Auto, they cannot become a trunk. Desirable, they can become a trunk. Auto means both will wait for each other to send for negotiation packet. But negotiation packet only will desirable will send or auto. And also remember one thing, native VLAN has to be same in the neighboring switch. If you take two switches now, both switch should have same native VLAN. Between two switches, இப்போ ரெண்டு switch எடுத்துக்கோனா ரெண்டு கடையில native VLAN சேமா இருக்கணும். If native VLAN is not same, then trunk will not function normally. Work ஆகாது. Okay, that's it. Fine. So I'll do the lab now. So for this lab, I'll do Inter-VLAN Routing lab. You take two PC. You take one router, then you take a switch. Then you connect them, all of these guys. So in the PC, I'll configure IP as 10.00.10. Default gateway is 10.0.0.1. In the PC, the IP is 20.00.10. Default gateway 20.0.0.1. In the switch, I'll configure FA0/3 as trunk port. Enable configure terminal interface FA0/3 switch port mode trunk. This FA0/1 switch port mode, switch port access VLAN 10 portalla. 2 switch port access VLAN 20 கொடுத்தரலாம். That's it. I can go back to my router. Here only main configuration comes. Enable interface FA0/0. First you unshut the interface. Then you go inside sub interface of one interface and say encapsulation .1q 10. In the 10 the VLAN number 10. Then give IP address same as your default gateway. Then you go inside FA0/0.20. Then inga 20 PC1 node default gateway. Sorry, we have to give encapsulation. I forgot. Encap.1q and then 20 and then no shutdown. That's it. Now I can go back to my PC. I can try pinging my IP address 20.00.10. So traffic will come all the way from PC to switch to router, from router to kilo. Now, just for you guys' reference, I'm gonna paste my command here. This is the main command I've used on my router. Enable interface fa 0/0. No, shutdown. Exit interface 0/0.10. So here is a command which I have used now. You guys can take a screenshot of this one. Apart from this, I made this port as a trunk port and this port as an access and access also. This is VLAN 10, VLAN 20. My PC is 10.0010, default gateway 10.1. This PC 20.10, default gateway is 20.1.